Today, we're doing something different. So we make the case for hybrid heat pumps,
Yes.
and then we tear it all down. So 101, what are hybrid heat pumps?
And actually, I usually just call them hybrids, hybrid HVAC, or dual fuel, which
Mm.
is what it is. I mean, you think about a hybrid car, you can plug it in or you can run it on gas. Um, and so to me, hybrid means two fuels, and that is what hybrid HVAC is. So most systems in northern climates in North America, so that's the Midwest where I'm from, the cold climates generally run a furnace and an air conditioner. And so the inside unit looks like it's a furnace, like I think of a basement. So a furnace on the bottom and then an air conditioner coil stacked on top. So it's two different pieces of equipment where if it's a heat pump product, there's no furnace, so there's no heat exchanger in it. So it's just one piece of equipment at that point. So anyway, if the standard system is a furnace and an air conditioner, a hybrid is a furnace and a heat pump. And it's important to understand like a heat pump can do cooling. An air conditioner and a heat pump are fundamentally the same piece of equipment, but a heat pump can run in reverse. And it has the piece of equipment in it called the reversing valve, which lets it reverse the refrigerant flow so that it can either heat or cool. And so if you stack a heat pump on top of a furnace, you have a hybrid or a dual fuel system, because it can be fired with either a fossil fuel, be that propane or fuel oil or natural gas. And then it can also use electricity to power the heat pump and heat the house. And it is a little bit strange. Like a heat pump at first sounds like, wait a minute, it's cold outside, but it's pulling heat out of it. Yeah, like you've got a device in your house probably running right now called the refrigerator that does just that. It's 40 degrees on the refrigerator side and 0 degrees Fahrenheit, excuse me, on the freezer side. So whatever that works out to be, 0 and minus 20 Celsius. But there is heat coming out of the back of that refrigerator. So it is pulling heat out of the cold air inside. So we know how to do this. We've been doing that forever. I mean, the first commercial fridges were like the 1930s. We're almost 100 years ago now. Right. So it seems strange that you can pull heat from the outdoor air, but you can. So a hybrid is a furnace plus a heat pump, which can pull heat out of the cold air outside and heat your house with it. Right. So that's the definition.
Okay. So what's the best case you can make for hybrid heat pumps?
Well, to me, the first critical piece, because I'm a comfort guy, is a hybrid is going to deliver, even with just mediocre single stage equipment, which is the norm. Something like 80 or 85% of equipment for homes sold is basic efficiency single stage. So it's on or it's off. There's no in the middle. But what you want to get better comfort is the output of whatever piece of equipment you have. You want it to be as close to what the house needs at that moment. So when it's 50 degrees, the house isn't losing heat all that quickly. When it's 0 degrees, it's losing it much more quickly.
Yeah.
Furnaces are generally 2 or 3 times larger than they need to be for most homes when it's cold. In fact, I've read that some gas companies actually model that the furnaces are running about a third of the time on a design day. So it's like it's actually somehow it's been known that they're oversized. Mm-hmm. So if your furnace is 3 times larger than it needs to be when it's very cold outside, it's 10 times larger than it needs to be when it's moderate outside. And so that means it's going to turn on and it's going to turn off. So you're going to get the blast of the heat and then it's going to shut off. And what that does is it may warm the temperature of the air in the house, but your couch is still cold. Your walls are still cold. Your ceiling is still cold. The floor in particular is still cold. Like if you wear slippers, and particularly on the moderate days, that's because your system's oversized. So a heat pump has much lower output. So like a really standard furnace size is 80,000 BTUs. The numbers don't necessarily matter that much, but it's 80,000 for a furnace. Standard heat pumps are 2 or 3 tons, which is 24 or 36,000 BTUs. So, a third, half the size, something like that. And so when it's moderate outside, 35 to 50 degrees Fahrenheit, 2 to 15 degrees Celsius, that is where your furnace is way oversized and it's not going to make your house comfortable. The heat pump will, or it will make it more comfortable because it is putting out much closer to what the house needs.
Right.
Now, if you move to like a variable speed piece of equipment, now it can match the house almost exactly. And that is shockingly comfortable. My good buddy, Cameron Taylor, who runs a couple of really crazy buildings for University of Texas, Arlington, like insane buildings. And he came and visited one of my projects years ago. I think it was 2015, 2016. And he said that the house had womb-like comfort. He's like, it was only set at like 55 or 60 degrees because it wasn't occupied at that time. And he comes in, he's like, where do I put my coat? This place is comfortable. And I've noticed that other times as well.
Yeah.
I mean, the first guy who got a Carrier Greenspeed, first client, I remember walking into the house and thinking, this is the most comfortable place I've ever been by an order of magnitude. And that was because of the heat pump matching what the house needed. That means everything around you is the same temperature, and it's a temperature that is balancing so our bodies are constantly trying to cool off because our bodies run on the warm side. Our bodies are always warmer than room temperature. And that's what you want, is you want it to be just incredibly comfortable so you don't even think about it. And a heat pump makes that much easier. Even if it's a basic single stage heat pump, it will do a far better job than a furnace, which is at least 10 times larger than it needs to be for those moderate temperatures.
Got it. So you're making a case for why hybrid heat pumps are better than a furnace.
Furnace and an air conditioner, yeah. I guess in this case, yeah, we're directly comparing. I'm talking the heating side, because the cooling side is assumed. An air conditioner or a heat pump both have the cooling side.
Yeah. Right. Existing furnaces in most homes are way oversized than they need to be, and they don't run nearly all the time, and they only run or cycle half the time or maybe a third of the time, like you were saying.
When it's very cold out, like that's at design temperatures, like where we only spend a few hours a year at those temperatures.
Whereas a hybrid heat pump setup, relative to a furnace, is able to better match the cooling load of a home, even if it's a single stage heat pump, because the heat pump side of it can be kind of like base load generation, or heats puts out a certain amount of heat consistently throughout, and then the furnace side of it can ramp up or down based on like the heating load of the house.
But one bit of nuance there, because I'm a nerd, sorry. So with the heat hybrid system, you can either run the heat pump or the furnace. You can't run them at the same time. Where with a heat pump only system, the heat pump can run and then you use the resistance backup to bump what's needed. So I view that like the afterburner in a jet. So, the jet's running along, but when you want to go really fast, you got to hit the afterburner. Where with the furnace is kind of its own afterburner because they have much larger outputs. So when it gets to where the heat pump can't handle the heating work, which there will be a point, like it may not matter in most climates, but in the northern climates, a basic heat pump is probably going to lose the war somewhere between 25 and 40 degrees Fahrenheit. With a basic system. The systems that I have been used to doing, they'll usually heat the house down to somewhere between 5 and 20 degrees Fahrenheit. So you get pretty cold before you need to engage the backup. But the furnace will take over when the heat pump can't do the job anymore. So it just automatically switches.
So regardless of what furnace you have today, if you have a central heating and cooling system, and you're heating with a furnace today and cooling with an air conditioning unit, the pathway to this hybrid system is when you're replacing the air conditioning part of it, you just put in a two-way air conditioning like a heat pump.
Yes.
And then what that does is, regardless of what size your furnace is and stuff like that, you just end up using less of that furnace over time. And
exactly. Yes.
Okay. Yeah. And that is preferable over something that is just an air conditioner.
Yeah. So, and that jumps to a point that I was going to make later, but you have two heat sources in this case. So should one or the other fail, it's not the end of the world. It's not a crisis. It's an annoyance. Where if the furnace goes and that's your only heating source, you're out of heat. Where if you have a hybrid, you have both. Now, to your scenario, if you have a furnace that is, say, 3 years old and an air conditioner that's 15, which happens, you could replace the air conditioner with a heat pump. The ideal is to replace them both at the same time, in my mind, both sides. Because then they're going to match. There's a bunch of sweetness that can come with that, but particularly if you move into midline or upper line equipment that's communicating, where everything talks to itself. So the indoor unit, the outdoor unit, the thermostat are all talking. Um, that's where the really killer comfort comes in, is the communicating systems. So, but you have to do the whole system to do that. But yeah, if you have a newer furnace and an older air conditioner, you could stack something like, well, the Bosch that I have in this house, you could stack that on top, and that could handle a huge chunk of your heating needs, depending on how leaky your house, how big it is, and how cold the area is where you live. So
Yeah.
yeah, it's nice. You have an automatic built-in backup with a
Yeah.
hybrid.
So why is a hybrid system, even if it's a single stage heat pump,
Hmm.
better at load matching than a furnace, especially if we're not replacing the furnace, right? So it's the same old furnace and it's also oversized. But now we have another piece of heating equipment. And now the furnace and the heating equipment have to interface somehow through a control system that
Hmm.
needs to figure out when a furnace needs to kick in or not. How is that better for load matching than just having a furnace?
Okay, so let's just use an example. Let's say it's 45 degrees outside,
Yeah,
or what is that, 12C,
sure.
and you need 10,000 BTUs to heat the house. But you have a 100,000 BTU furnace
Hmm.
and a 36,000 BTU heat pump,
Hmm.
which would have been your air conditioner. So that's a relatively standard matchup. I think it's a stupid matchup, but it's quite standard. They're both too big. But if you're trying to get 10,000 BTUs and your options are 100 or 36, and you
Hmm.
want it to run as much as possible, that heat pump's going to run 3 times as long as the furnace. Now, if you make that a 2-ton heat pump, now it's going to run 4 times as long. And so it's going to be putting a continuous stream of heated air into the house, and that's going to tend to warm all the surfaces and the materials in the house up. That's got the nerdy name of mean radiant temperature. It's the average of the surface temperatures around you, is what it is. So I know that's nerdy, but that's what it's called, and it is absolutely magical when you can load match. So even a single stage system is going to run 2 to 4 times longer than the furnace is in general.
Got it.
And that's what you need. The goal, and I should say, this is something I need to say more clearly. The goal of an HVAC system is for it to run 100% of the time at very low levels. So you think about like going down the highway. Do you ever take your foot off the throttle? No, but you're just barely into the throttle.
Yeah.
And that gives you a really smooth ride. Where
Mm.
if you've ever ridden with somebody who is not smooth, they're can you please use the cruise control because you're giving me a headache, dude. And driving with a furnace is like that. It's
Yeah.
like you have 400 horsepower or nothing. And with the heat pump, you have 100 horsepower or nothing if it's a single stage. Or if you have a variable speed piece of equipment, you can go down to, say, 25 horsepower.
Right.
And driving on the highway, most cars need somewhere between 10 and 40 horsepower to keep them going at say 55 or 60 miles an hour, like a
Mhm.
relatively low highway speed. It doesn't take much to keep a car going. So we're trying to make the system run all the time. And a hybrid is going to do a far better job than an air conditioner and a furnace at that
Got
job.
it. Got it. And the heat pump side of it is the first stop for getting heat, I guess, right? And then
Yes.
once its capabilities are exhausted, then the system will ramp up the furnace side
You'll
of it.
turn the furnace on. Yeah.
Yeah, and so that way, inevitably, regardless of how, I guess, very basic your heat pump system, heating side of your heat pump setup is, you're still using less gas than you did before, but you're
Yep.
also matching load for most part of the winter, right? And so, but having a hybrid setup would just make it easier for the heat pump will take care of my needs for the most part, right? Even the most basic thing that was designed for cooling, with heating being an auxiliary thing, would probably take care of my needs in well into September, October, possibly even some parts of November. And then when it gets really cold, then the furnace kicks in. And then
Exactly. Yeah.
would I
There's a couple
notice?
different ways to control it. So you can have it where it flips from one to the other at a certain outdoor temperature. If you have a smart thermostat that it usually goes and pulls data from the nearest airport, or the most common setup is called droop, where say when it goes a half degree below set point, it kicks the heat pump. And
Got
if
it.
it ever gets to a degree or a degree and a half below, it fires the furnace. So
Got
it
it.
only fires it when it starts losing the war.
Hmm.
So that's the droop method.
Yeah.
So those are the two primary ways that they get controlled.
And this would work for most homes with central ducting, right? Without any additional.
Precisely. That's one of the key things because, like, heat pumps, if you are sizing for heating in a house that has a relatively high heat load, you need to be able to flow a lot of air through the ductwork. And that will typically lead to very high pressures, high energy use, and very high noise, oftentimes, and very early failures. You can start losing components components of the systems in a year or two. Like, not every time, but I hear plenty of systems breaking things in 12 to 24 months, maybe 36.
Mhm.
That's not good, because a well-designed, well-installed system should still last 15 or 20 years. They typically are only lasting 8 to 12.